Hey everybody, welcome to the Soft Spoken Scientist channel. Today we're going to be discussing percent yield and solving for them. And I think that it'll make a lot more sense after this session. So grab a pen and let's get started, all right? So let's talk about this. There is a formula you guys need to know. Percent yield equals the actual yield divided by the theoretical yield times 100%. Actual yield always goes on top, theoretical yield always goes on the bottom. And I think the takeaway that you guys should know about actual yield, I might just move that there, and theoretical yield, is that actual yield is the amount of product you actually obtain from your experiment or your lab. You actually have it, okay? The theoretical yield is the amount of product you calculate should be produced based on stoichiometry, assuming the reaction goes perfectly, all right? So theoretical is like theoretically, it's like a dream, something you wish, should be produced, not a wish. And then the actual yield is the actual reality. What did you actually obtain? I think you guys got that. Okay, so this is the formula, and people sometimes mistake it. You could always think of it like in alphabetical order. The A is above T in the alphabet. That's how I recalled it. Okay, so let's do a practice problem. A reaction has a theoretical yield of 50 grams of product. The actual yield obtained is 42.5 grams. Calculate the percent yield. So the actual yield is 42.5 grams. They literally just told us that. So I'm going to write it in the numerator. The theoretical yield is our desire of 50.0 grams. I'm going to substitute into the formula, and then I have the percent yield, all right, equals 42.5 divided by 50.0 times 100%. Just like the formula. All I do is plug it in, you guys. And when I plug it in and perform the calculation, I get 85.0%. So percent yield is usually less than 100% in real experiments. That's how you know you did it right. Okay, let's try this one, and then we'll go on to harder ones. The theoretical yield of a product is 18.0 grams. Remember, the alphabet, T is at the bottom. Actual yield is 13.9 grams. All right, times 100% for the percent yield. When you plug that into your calculator, you are going to get 77.2%. Now you may be saying, why three digits? I have one significant figure, another one, and another one. One right here, and the 0 counts after the decimal point. So 77.2%, all right? Keep significant figures consistent with the given data. Let's try number 3, it's a bit more of a doozy. From a limiting reactant calculation, the theoretical yield of NH3 is 12.0 grams. The actual yield collected is 9.60 grams. Calculate the percent yield, and it's going to get harder as we go on. The percent yield, right? Okay, so the percent yield is A over T times 100%, all right? So I know my actual yield is 9.60. I know my theoretical is 12.0 times 100%, and then that would be 80.0%. Once theoretical yield is known, percent yield is straightforward. Now we're going to do a reverse problem. You're going to find the actual yield. Okay. A reaction has a percent yield of 82.0%. The theoretical yield is 25.0 grams. Find the actual yield. So the step 1 is you convert your percent into a decimal. When you have 82.0, you divide that by 100, and you're going to get 0.820, okay? 0.820. And the reason I added the zeros because this was 3 sig figs, so I just added a 0 after the decimal point, because this does not count as a sig fig, but these 3 do, okay? So now I have to rearrange the formula. So I had percent yield equals actual divided by theoretical, right? Now I'm going to get the actual yield, I'm going to multiply by theoretical on both sides. Remember, guys, what I do on one side, I got to do to the other. So then I have actual equals theoretical yield times the percent yield. All right? So I'm going to take the theoretical yield, which is 25.0. I'm going to multiply it by the percent yield of 0.820. And when I plug that into the calculator, I get 20.5 grams. All right? Now you may be saying, well, what about the 100% thing? That's part of the percent yield answer of 82.0. So I don't need to worry about that, and I just did everything else. Exams often test percent yield backwards like this. So high yield, you guys. Let's try another one. Now they're tricking us again. Now they want us to find the theoretical yield. The actual yield is 21.0 grams. The percent yield is 70.0%. Calculate the theoretical yield. So we know that its percent yield equals A over T. Okay? I'm going to multiply both sides by T because I can't have something in the denominator. The T's will cancel out. And then I have T times the percent yield equals actual yield. I'm going to divide both sides by the percent yield. So I get T by itself. And by doing that, these cancel out on one side, and I have T equals A over percent yield. All right? So I'm going to calculate the theoretical yield. The A is 21.0 grams. The percent yield. Remember, we got to turn the percentage into a decimal. So if you do 70.0 divided by 100, you will get 0.700. And I made it 3 sig figs after the decimal point. So I'm going to plug in 0.700 in the formula. I'm not going to be plugging in 70%. That'd be crazy. Okay, by doing the division, I got 30.0 grams. And that wasn't too hard, just because I knew, like, 21 divided by 7 is 3, and then the digits. But you'll get a calculator probably for that. So the final answer is 30.0 grams. Let's look at question 6. A reaction produces 0.455 moles of product. The theoretical yield was 0.600 moles. Calculate the percent yield. Okay, so the theoretical yield, as we know, was 0.600, and we produced 0.455 moles of product, all right? You don't even need to include units on this part, times 100. And by doing this division, first on your calculator, do the division part, and then multiply by 100%. Just play it safe. You're going to get 75.8%. All right? Percent yield can use grams or moles. As long as units match, then guess what? You did the answer right. You got the answer right. Number 7. A student calculates a percent yield of 108%. Is this possible? Remember, we talked about this. In theory, percent yield should not exceed 100%, but values above 100% can occur due to impurities. You can even write about this in your lab report. Impurities, measurement error. Some teachers like it when you say human error. It just depends. Some people hate it. Measurement error, impurities, safe bet, or incomplete drying of product. All right? Most percent yield mistakes come from flipping the numerator and the denominator. But remember, A and then T is in the denominator. Like, the word, you know, A is first in the alphabet, at. Think about the word at. So, percent yield problems follow the same pattern every time. Write out the formula, substitute it carefully, rearrange the formula, and I think you guys will be all right. Thank you guys so much for watching. Please like and subscribe for more general chemistry problem walkthroughs, and I want you to remember STEM is for everybody, but especially you. Let's get it, guys.